was starting to think about removing some corrosion when I noticed that I can definitely take some of this chassis apart, like this piece on the back here, take off 1/4 inch nut on either side and one there, it'll come right out. Looks like there's one missing here, I don't know where that went. Also missing, someone has noticed, is all the antenna terminals. Should have been some screw terminals back here. You can attach your antenna to it. I don't know what happened with that. You might just end up drilling out those rivets and trying to find a replacement for it. So with these out, I can dump them in a bucket of evaporust. Instead of messing around with navel jelly. So get that to squeaky clean with minimal effort. My side pieces, well, I disconnected all the wires, took out the coils. Could take these screws out and I'll see how much is actually attached underneath. Tube sockets could probably survive. Evaporust is pretty benign stuff. It uses a process called chelation. There's no acid in it. It's more akin to antifreeze, I think, or anything else. And it really just attacks rust. So I could probably dump this whole chassis in it. I was really feeling brave, but I don't think it'll get. I don't think it'll go that far. Well, the rustiest thing I'm seeing is these tube shield bases. Oh no, these 1/4 inch screws for sure. I can take these out and chuck them in evaporust. In the end, I decided to just go for it and took off the side of the chassis and unwired the 2 IF cans. It actually wasn't that bad. There are only a couple wires still connected going from this little subassembly to the rest of the main chassis. This also held the volume control, which I disconnected, so I can check that for continuity and clean it out. Do the same for the IF cans. I'll check for continuity. I don't think there's any mica caps inside that I need to be concerned about. But I'll take a peek, and then it'll give me a chance to remove the rust from these 2 nuts. Take out these nuts, and the insides just pull out. There are mica caps in here, but they're not the kind that usually present problems. They'll be underneath these screws. There'll be sheets of mica between 2 pieces of metal, and these screws compress or decompress the little sandwich there. I've never had a problem with one of those. Which leaves this. I took out all the components that were on here. It looks like, again, one of these terminals broke off. So I'm guessing when this was worked on before, a little bit of damage was incurred while working on it. So just have to deal with that. It explains the little weird mess I found in there of components that were just attached in free air because they were in this area. They probably used to be attached to this terminal, which is no longer there, so let's figure out something to do with that. Speaking of figuring out what to do, so here we are with the corrosion. So what do? Could spend a lot of time with Q-tips and navel jelly to get that off, but one problem you can have with that is these rivets, I believe, are brass, and navel jelly and brass don't get along too well. So what I propose doing is I am just going to dunk this into the evaporust, see what happens. I'll take off as much as I can before. In fact, maybe I'll just go ahead and take all the wiring off. I don't think the sockets are going to be a problem. Yes, they will get damp, but I will dry this out thoroughly once it's derusted. And make sure there's no moisture still down in there. Hey, worst case scenario, if it is a problem, I can always drill out these rivets and replace the sockets if I have to. They're just octal sockets, nothing particularly special. I'm also curious to see if this technique will work so I can use it in the future. Because I do not want to spend hours with Q-tips getting down in all those nooks and crannies. Don't want to put that much time and effort into this. Here it is after soaking overnight in some evaporust, and as usual did a great job. All the corrosion is gone. Did not harm the plating. Did not harm these eyelets, which I think are brass. Now, of course, corrosion could come back, so what to do to prevent it? Well, it could clear coat it, but you got to be careful with that. You got to cover up the tube sockets, and this screws into other parts of the chassis, and you have to get a really good, solid ground connection. So you'd have to scrape away or mask off, say, where all these screws go and where surfaces meet other parts. And you don't want to get the spray on any of these points where you're going to be soldering. You know, the solder, you could melt through it, but you'd create some nasty fumes. Another option is to do nothing. If you get this really bone dry and keep it in a dry environment, it'll be a long while before the corrosion comes back. Or you could use a product you've seen me probably used before, which is this T9. I was tipped off to this product a year or two ago, and I've been using it a lot since. What this is wax, I think paraffin or something like that, in a solvent to make it very liquidy. This was developed by Boeing to prevent corrosion, and basically you put a little on here and you smear it all around good. I just use my finger most of the time and just go like that. And as the solvent evaporates, it leaves a thin coating of wax over the metal. Now, yes, you still have the same possible issue of not getting good ground contact, so you want to make sure you clean it off on around areas that are going to make they're going to make ground contact with other parts, but you don't have to worry about masking off all this stuff, and you can reapply it as needed. It's definitely good for years. I'm not sure exactly how long. Well, this says months on here. Well, I've had things that I've coated upwards of 2 years ago and seem to be fine. Another product is this. It's very similar, but this is water-based, so you don't have the solvents. Exactly the same concept. It's a wax-type product, just a different solvent carrier to it. Alright, so I got that done, and I broke down the rest of the chassis, and I've been doing the other pieces, all coming along nicely. And I got to this finally, which was the power supply. I mounted the transformer. I'll get the corrosion off this and repaint it. Just take off these two bolts, and this part should come off, I hope. I've never actually seen the insides on one of these. I'm kind of curious to see how that's wired in. I can see there's a couple little tabs here bent over, little forks. I might need to bend those up. Might be more trouble than it's worth. I could just leave this together and repaint it too. And I want to slip some heat shrink tubing over some of these wires. They are starting to break. So these wires from the 30s, inside of these is something called gutta percha, I think is how it's pronounced, which is kind of like a tar-like substance. So it's, excuse me, the metal braided wiring, and then a gutta percha, and then cloth over it. This gutta percha over time dries out and gets rock hard, and that's what's cracking when you bend these wires. And you see to the point where they start getting exposed to the insulation. So one thing that helps make it easier to slide the heat shrink tubing over this is if you heat these wires up a little bit, they become flexible again for a while until they cool off. So I'll show you on this guy. I'm just applying a little bit of pressure. As the wire warms up, I'll be able to pull it straight again. You can see here this heat shrink tubing remnants from when I was testing this with the AC line. A similar deal. Even better, if you've got a rainbow assortment of colors, you can match up with the original wire coloring was. These are a bit faded. This is supposed to be blue, I think, for example. It's kind of dark green now. So where I've heated this, it's now pliable, bendable, just like when it was new. But alas, it will not stay that way. So I definitely want to recoat it. I suppose if one wanted to go to the extremes, if you could take this clamshell off and get down in there, you could probably replace these wires entirely going back to where they're attached to the transformer windings. Alright, so we're left with this. Take this off, and I need to restuff this with those safety caps. And we have two things left on this before I dunk it into the evapo-rust. This, which is a bias resistor, it appears to be original. It's riveted on here and it looks like it has a Philco part number on it. 393299, I think. 333299. What I'm curious about is it doesn't look like what they show in the parts diagram. And I've never seen one quite like that in a Philco before. You can see on here it looks like a big cylinder with a bolt on it. Let's see, it's part 68. 333276. So it is a different part number. However, it looks like that's the original rivet, and it does test good. So maybe it's a production run change, I don't know. But this is what they normally look like. Well, this one would have one less tap on it. So I'm not sure what I want to do about that. The other thing is the sockets. I've noticed some corrosion on some of the other sockets too. I'm thinking it may have been because of the environment that this radio is stored in, which seems to have been damp. Or perhaps the guy who was working on restoring this before tried using some like navel jelly or some other rust removing product, or sprayed something on this and that started corroding the tube socket pins. Well, because of the corrosion, which I don't want to deal with, I could spray deoxit in there and get little pipe cleaners and run it down there and clean off the corrosion. Or I could just replace the sockets. I happen to have some on hand that are never been used. Very nice sockets. They're for mounting underneath the chassis, so they're threaded down below, and you mount them from underneath. The holes, the mounting holes will line up, and the pins are oriented the same way. So if I drill out those rivets and slide this over, it'll plop right in there. And I'll have nice, clean, new socket pins to deal with. And then I also won't care about moisture getting in here. I think that's the way to go. These are the 6F6 push-pull output tubes. Otherwise, could have a problem with moisture getting in there, or a bigger issue I think would be the corroded pins. I just noticed something. I was wondering what this plug was for here. Why it was plugging up a hole. I think that is where the old bias resistor would have mounted, because that's the kind of like keyhole mount they used. Get that resistor back out here. Show you what I mean. Now this is not the right part number. Not sure what this came from. I don't know if I can dig one above the correct part number, but there's a square bolt head on that, and that would mount in and then slide over. See if this fits. And mount in like that. So I think that could be a production run change. So that sure fits that square bolt like Philco used to use. And have this on the other side. Curious. So I'm not a big fan of these canned ohm resistors. See the way they work, I think you can see down in there, there's wire, insulating wire wrapped around an insulating rectangular form. Then these are just pinched around that insulating layer, and then this outer metal sheath is pinched over that. What can happen to these is they can corrode, because pretty well exposed to the elements, and also you can have issues with this tension's not tight enough, the whole sandwich doesn't make good contact, and you lose connectivity. Now, it's entirely possible that this isn't original and somebody just drilled a hole and pop riveted that thing on. So that rivet's not the greatest job. In fact, if I was to put a little bit of pressure on this right now, I think it would pop right out, because that rivet head is actually down flush into the sheet metal. Like the hole they drilled for that rivet was actually a little too large. Well, ponder that, but I'm going to go ahead and take these tube sockets out. Sometimes these holes, which are hollow rivets here, have a grid cap lead coming up through to attach to the top, and it goes inside of the tube shield, something like that. But these do not, so I can just use regular screws to remount mount the new socket, and I don't care about plugging up these holes. Here's one of them removed. Just need to clear out remains of this rivet. And I can see that there's corrosion that was underneath that socket, so now I'm especially glad I took them out. And I'll be doing similar operation to the RF chassis. And you may recall, if you watched the earlier video, sockets had tape over them. And I can see characteristic pink residue of somebody using navel jelly. So I think you put tape over these and then we started using navel jelly to clear off the corrosion. And these also have some of that pin corrosion on the other side. So I may end up replacing these two sockets as well.